Stanford University.
Alrighty then, Lecture 13 of Stanford CS 193P, spring of 2020. Today, our topic is persistence. That is to say, storing stuff that lives between launches of your application. Now, we've actually seen quite a bit of this stuff already, and we're going to go into some more detail on the last two down there, CloudKit and file system. But let's do a quick review of what we've learned about persistence. We know about user defaults. It's simple, quite limited, only lets you store these property lists. It's small, it only stores a little bit of data. It's also pre-Swift, it's kind of a clunky API, but it's really good for demos, and that's why we've used it so much this quarter. And we learned about Codable and JSON earlier as well. Great way to take a custom struct that we've designed and turn it into a nice interoperable format, either that we would send over the internet or maybe that we would store on disk. Now, for those of you who looked into the en route code that I wrote that got the data from FlightAware would see that that data from FlightAware comes as JSON. And I just use Codable to turn it into a local struct. So that's another use of Codable, is receiving data from people in JSON format. This UI document is something that is part of UIKit. So we're not really going to talk about it in this class. This is a Swift UI class. However, if you have an application like EmojiArt that really has what the user perceives to be a document that they're creating, you almost certainly would want to use this UI document infrastructure. This is not going to be something that you're going to do for your final project. It's not that it's really advanced API as much as it requires UIKit integration and some concepts there that we just don't have time to cover, bottom line. But I'm mentioning it just so you know it's out there, because if you went out in the real world and you created some kind of app that has a document, you want to know about UI document. And there's core data, of course, powerful, object-oriented, has incredibly great Swift UI integration through that fetched results stuff. And this is really the go-to place when we want to store data in an iOS app. We're going to use core data. If it's any significant amount of data, we're going to do this. We're not going to put in user defaults unless we're doing a demo. We're going to use core data. And you saw why. It's really a very capable database system. CloudKit is something I'm going to talk about today, and it's a way to store data on the network in iCloud. And you can see there's some huge advantages of doing that. When you put stuff out on the network, it means that now the user's going to see all that data on all of their devices instead of just on the device they created the EmojiArt thing on, or the theme in their Memorize. So that's really, really powerful thing to be able to do, store things on the network. CloudKit has some nice features that are similar to what you already know. For example, it has its own little user defaults-like thing where you can store key value pairs on the network that are shared on all devices for that user. And it also can play really nicely with core data. I don't know if you remember when we did the new project and we clicked the use core data button there was another one that said, oh, and use CloudKit too. And that will make it so that your core data databases get replicated using CloudKit on all of the user's devices. So anything they put in core data, they see everywhere. That's a powerful combo right there. And CloudKit also has a mechanism for storing documents out there. So there's some integration with UI document and all that to make a document store. So CloudKit is really, iCloud in general, really awesome mechanism for saving things on the network so the user can see them on all of their devices. Now we're going to go over the basics of CloudKit today via slide. I just want to give you a feel for what it's like. This is an API you might want to try and use for your final project. It's a little ambitious, and I'm going to show you the ways you can cut corners just a little bit for your final project, just so you should introduce yourself to this. This is an introductory course after all. But I think some of you might find, wow, I really need a way to store stuff that would work on all the users' devices. And so CloudKit might be a nice your choice API from the rubric. Then the next topic I'm going to talk about after CloudKit is the file system, essentially accessing things in the file system, which we do via URL and data, which you already know about those structs, and also a new struct called File Manager. I'll talk about how these things work, and then I'm actually going to do a demo on this one where we're going to make our EmojiArt documents be stored in the file system. So CloudKit, what is it? It's a database in the cloud. Now, it's a simple to use database, has basic database operation, not as fully featured as core data. This is not core data over the network, all right? And one of the most important things to understand about doing CloudKit database is that it's asynchronous. All of the important calls that do things in CloudKit are asynchronous. You provide them a closure, it goes off and does it on a background thread, and when it's done, it calls your closure back and said, here's what happened. That kind of programming, asynchronous programming, takes some getting used to. You already saw it a little bit so far in this course, but CloudKit is intensively asynchronous. By its very nature, it's going out over the network, which the network might be unavailable, or it might be slow, or whatever. Demoing this is, because of that, can be quite a big demo, even bigger than core data demo. So I'm not going to do a demo this quarter. If you want to go back to spring of 2015-16, this course was on iTunes U. You can, I think it's still there on iTunes U. You can go watch it and see the CloudKit demo that we did, and most of that's still applicable. All this CloudKit stuff is pre-Swift UI, pre-Swift even, and so the stuff hasn't changed that much since then. You'll get the basic idea if you want to go back and watch that. All right, so let's do an overview of CloudKit. I just want to define some terms that we use in CloudKit a lot so we understand what we're talking about. The first term is record type. So a record type is like a class or a struct. There's really no classes or structs per se stored in CloudKit. It's not like core data where we essentially looks like objects to us, but we do have these things called record types, and that's a kind of thing that's in the database. Then the word fields is what we use for vars. In core data, we call these attributes. In CloudKit, we call them fields. This is the vars, the things that exist in our record types that we store. Then there's the word record. Record means an instance of a record type. So it's an actual one of those things in the database. So of course, you're going to be storing many, many records in your CloudKit database. And that's where all your data is. And the records contain values for all the fields. There's something called a reference, capital R, a reference, a CK reference. You're going to see CK in front of all the things that we do in CloudKit. And that is a pointer to another record. Doing relationships between records, record types, is not quite the same or as powerful as we have in core data, where it's automatically keeping a set of the objects on the other side and it keeps it up to date and all that business. This is not a full relational database by any means here. So references between objects still make sense, but you have to do them with this CK reference, this reference to the other object. And I'll show you what that looks like in code. Then there are terms like database, zone, and container. A container is a collection of databases. A database can have zones inside of it. This is just how we partition up the space out in iCloud that we want to store our data in. And I'm going to talk a little bit briefly about this. I'll talk mostly about the top level databases that we use. We're going to use one of three databases, and you'll see that. Then there's something called a query. A query is a database search. This is where we're going to go out in the database and try and find some records, some instances of some record type that match some criteria. And that's going to look very familiar to you when we get to that. And finally, there is a subscription. So this is like a standing query. And we talked about the standing queries in core data where we had these Swift UI fetch requests that return these fetch results. And that was a standing query. It was always updating them. Well, here's a standing query too, but it's a lot more complicated to have a standing query on the network because you're talking about finding out when something changes in iCloud and then notifying your app, whoa, this query that you set up to be always querying, it changed, but it changed on the network and you get notified. And the way your app gets notified is via something called a push notification. These are the little things that come down to your phone and tell you certain things have happened. A lot of apps have these push notifications, and that's how this works. Now, that's way beyond the scope of this class to talk about how push notifications work and how you would react to them. This is not something I would expect you to do on your final project, is to have a subscription, a standing query, and handle the push notifications. You have 3 weeks to do your project. I don't want you spending a whole week on it trying to do that. So I would, if you're going to do CloudKit for your final project, I would not tackle subscriptions. One thing about using CloudKit is that it requires a little bit of enabling. You're used to just, import core data and I can start using core data, and that's true for core data. But for CloudKit, you actually need to turn it on. And if you go to the Capabilities tab in your project settings, you're going to see there's a bunch of capabilities like Apple Pay and Game Center and things like that that you have to turn on. And that's because these things are accessing servers out there in the world, so they need a little bit of kind of authorization and enablement, entitlements we call these things, to make your app be able to do these. But it's quite easy to do. You just go in here to this Capabilities tab, and where you see iCloud, it says off when you get in there. Just click it to on, and you're going to get some more UI here. And you can see there's 3 different services in CloudKit. The first one there, key value storage, that's the user defaults like thing I was telling you about. And then iCloud documents right there, that's for storing your documents in iCloud. I was telling you about that. And what we're going to talk about is CloudKit, which is this database, right? The database with records and fields and all that. So you're going to turn that on, and then you're going to go down to this button right below, very important button, CloudKit Dashboard. This CloudKit dashboard is going to let you manage all your activity in CloudKit, all your record types, all your records, see all your data, queries, everything is going to be managed through this. Let's click on this button, or simulate clicking on this button, and see what we get. This is what you get. You go to a certain website on the internet, and it probably doesn't look exactly like this anymore. This says created May 15, 2016. So this is kind of old, but it's still same idea what's going on up there, which is that you are looking at all the records and record types that you have, and you're even marking them. You see on the right there where it says query, search, sort, query, search. You're marking which things you want to be able to query and which things you want to be able to sort on, etc. You can add record types and fields and all that stuff here, although you usually don't do that, because something very interesting about CloudKit when it comes to adding record types and fields, which is that it has dynamic schema creation. So you kind of look at that dashboard and you think, oh, that's kind of like the map we had with core data. And it kind of is. It serves a lot of the same function. However, in core data, you have to do the map. The map is how your app knows what classes and vars to create for you so you can access the data. Where in CloudKit, you don't have to do the map. It can build the map on the fly. If you create a record type with a certain name, it just creates that on the very first time you ever do it, boom, it creates it. Now, it only does this dynamic creation of the record types and fields and stuff while you're in development. And eventually when your app ships, when you go to the App Store, the iTunes Connect, where you set up to have your app be on the App Store, you're going to click a button that says, okay, I'm switching over to production mode on my CloudKit, and then it's not going to let you do this dynamic schema creation. Of course, right? You do the dynamic schema creation while you're in development. Once you get that to the record types and fields and stuff you want, then you go live. Let's take a look briefly at what the code looks like when you're writing a CloudKit app. The first thing you need is a database to put things in. It's just kind of like a managed object context, but not really, because it's much, much more lighter weight concept, this database. But the most important thing you're choosing between is whether you want a public database, a shared database, or the private database. So the private database is the normal iCloud database. This is just the database where you put stuff that is the user's, and the user sees it on all their devices. That's the normal database. The shared and public are kind of interesting ones. The public one, if a user puts stuff in the public database for themselves, then other users, if they know the person's iCloud email address or whatever, they can actually look, their app can go look and see that data. So it's really kind of publicly posted data. You can think of it as like, your website. You're making the stuff available to people and they can see it all they want. Pretty rare to do this in iCloud, but you could do it. Essentially a way to use iCloud to publish information to the world. And then there's shared, which is invitation-only access to your private database. And the way this works is you end up sending an email to people. And in that email is a link, and when they click on it, their little iCloud shared database gets a view onto some part of, not your entire private cloud database, of someone else. So that way the two of you can share data, and both sides can add objects or whatever, depending on the permissions granted, add objects and see each other's objects. And again, it's only a little subpart of the database, but it's a kind of a cool way to share things. So once you have a database, then you can start creating records. And here's how you do that. To create a record, you just say CK record and the name of the record. And again, you don't have to have gone to the dashboard first. You can just do this. And if this is the first time I've ever created a CK record, quote, tweet, then now tweets, or record type tweet, is just going to be created in the database for you. And then to set the values of fields, it kind of looks like accessing a dictionary. You say tweet, open square bracket, the name of the field, equals the value. And that is going to, again, create that text field in the tweet record type, if that doesn't exist before, and set its value to that. And here I'll create another one. This is a CK record for a Twitter user. So it's a different record type, a different kind of thing. I'm going back to my tweet and setting its tweeter field to be a reference to the tweeter. So see here, I'm having to say CK reference with the record of this Twitter user I created. A little different again from core data. You can't just set it directly. You got to do a CK reference thing. And then notice that action that says things like, basically determines what happens if the tweet gets deleted. Does the Twitter user get deleted? Things like that, those kind of relationships. So that's how we build up our record types and our records and their fields and the references to other objects. And once we've kind of done that, then we want to save it. And this is where we're going to hit the network. So this is an asynchronous function. It's just called save. You just give it the record, the CK record you want to save. And it's going to go off on the network in the background. It might take a long time if the network's down, or it might fail if the network's down eventually. But if it can finally get through and write the information that you want, this tweet record, then it's going to call this closure that you give it back. And this closure that you give it has two arguments. One is the record that it saved, if it was successful. And the other one is the error that was generated if it was not. So this is, again, pretty Swift. In Swift, we'd probably have an enum here with success and failure and associated value of the record for success and associated value of the error. But we don't have any of that. It's all pretty Swift. So one or the other of these two things, the saved record or the error, is going to be nil. If the error is nil, then woo, success, you saved that thing, and the saved record will be the CK record you just saved. But if the error is not nil, then you got to start looking at the error codes and figure out what went wrong. And it's the network, so a lot of things can go wrong. There are 29 different, at last count, CK error codes. Now, you don't have to check every single one because some of them can't happen during a save. Some errors happen in other things. But if you're really doing this for real and shipping your app, you'd want to check all the ones that could reasonably happen here and decide what your app is going to do because you weren't able to save this record. Here's a place, again, if you're doing your final project, I'm not going to hold it against you if you don't check all these error codes. Maybe check error codes in one place just to show me you understand, that you got to check error codes, but otherwise don't check them, and then your app, your final project basically would just fail miserably in bad networking conditions. That's okay. This is intro class. You're just trying to introduce yourself to APIs like CloudKit. You're not trying to be a master of it all by the end of this quarter. And that reduces the scope quite a bit of doing CloudKit. A lot of CloudKit is handling these errors and the infrastructure for what you do when you can't write things out to iCloud. And so hopefully it reduces the scope to something where you could realistically do it as a final project API. Now, what about querying records, searching for records? And this ought to look real familiar to you. Yes, it's NS predicate, the exact same NS predicate from core data. It has the same object. Now, you can't have exactly the same formats there because the CloudKit database is not quite as powerful as core data. So core data can do some things in there that CloudKit can't, but basic stuff like equals and does this text contain this search string, for example? This is, let's say, a tweet that we're searching on right here. That is perfectly reasonable to do. So you create the predicate you want, and then you create something called a CK query, which just is the record type that you're trying to find, that you're searching for essentially, and that predicate. So again, similar to a fetch request in core data, similar, but not exactly the same, but you get the idea. And then to execute the query, of course, you're going to have to go out onto the network. So that's where this function perform comes in. You give it the query you want, and then you give it a closure, and that closure will be called when this thing either fails or succeeds. And that closure has two arguments as well. One is an optional array of the records that it found by doing that search for you, or an error. And again, if it's an error, you have to deal with the fact that things that you were looking for fail to even search for them. And if it's not, then the records will not be nil. It'll be an array of CK record, and there you go. There's your CK records that you were looking for. So fairly straightforward to do searching in CloudKit as well. These standing queries are just, you take one of those CK queries and you essentially communicate it to the database, and then it's doing the query on the server side. And then whenever a new thing gets created that changes the result of that query, it sends you this push notification. And if you do want to try and check out how do I handle push notifications and what do I do, feel free to try and jump on that. Again, I think a little too much for your final project here. You can take a look at the user notifications framework, not just for push notifications, but also for doing local notifications too. You might want to check that out. Those are kind of fun. That's just where you kind of can set little calendar events almost, things to go off at a certain time when your app wants to remind the user of something or do something in a timely manner or something. All right, that's it for CloudKit. That's the intro to CloudKit. Let's talk a little bit about the file system. iOS devices, I don't know if you all are aware, but they are essentially Unix OSs at the heart of them. And they have a Unix file system there, Unix-like file system. And it starts at /, just like all Unix file systems. But of course it has protections, and you cannot see or write into most of the Unix file system there. And the area you can see and write into, though, is called your sandbox. And your sandbox completely isolates you from the rest of the world. Your app can't see into other app sandboxes. You can't see outside your sandbox to modify the system, of course, and damage it in any way. And this is a really great idea, sandboxes. I wish we had this on Windows and Mac and normal operating systems. Obviously it makes a ton of sense on the devices where you're installing and uninstalling these apps for each of them to have their own sandbox. Now, why do we do this sandbox? Three main reasons here. One is security. You don't want anyone to reach into your sandbox and damage your app in some way by affecting its data or doing something bad. Also, privacy. Your app obviously is collecting data from the user, and you don't want other apps to be able to see what that data is. And a really underrated but powerful part of it is cleanup. If someone deletes your app from your device, you want everything that app has ever created or touched to disappear. And that's what happens when you delete your app. The sandbox is completely removed, and so everything the person's ever created. Now, the sandbox has directories in it which are backed up to iCloud when the user has iCloud backups on. So if someone deleted an app and then said, oh no, my documents were in there, they can go back and get them. By the way, when it comes to storing documents, a lot of times we'd want to store our documents in iCloud. That way, if we deleted an app off of my device, it would still be on my other devices. And if I reinstall the app, I would see them from iCloud. That's why it's a really good idea to store our documents in iCloud. All right, so what's in this sandbox? Well, there's a bunch of directories, special directories, kind of specially named directories. One of them is the application directory. This is where your executable is, any JPEGs or images or anything else that you drag into Xcode to make your app work. Those live in there, and they're read-only there. No, you're not allowed to change your application, add images to it or whatever. You'd have to do that in other places. Another really important directory is the documents directory. This is where you store what the user perceives as a document. For example, your EmojiArt documents would definitely be stored here. If you didn't store them in iCloud, you would definitely store them here. But something like the emoji palette, or maybe your memorized themes even, you probably would not store here. The user does not really perceive them as documents. Those things would be stored in the application support directory. That's another directory. Gets backed up by iCloud. It's permanent, but the user doesn't see them as documents in there. Kind of data that the user is creating, but not really document oriented. A subtle distinction there, and it really doesn't matter too much how you do that unless you're using the UI document stuff. If you're using UI document that I mentioned earlier, then you definitely want those documents and only those documents going in the document structure. You don't want to put those in application support, nor would you want to put application support stuff in the document structure, confusing the user about what's in there. And there's a caches directory. This is temporary storage. So this is storage that does not get backed up into iCloud. And if you deleted your sandbox, it's gone forever. So this would be things that you can like easily get from the internet again. Images that you're just caching locally so that for good performance. But if you had to throw away the caches directory, you could, and your app would still work because it would just re-download whatever it needed from that caches directory. You know, if the iOS's disk started to get full, the iOS might start hunting around looking for caches directories and sandboxes that are really big that it can blast to get space back to. Rarely happens. Most people's iOS devices do not get full disks, but it could happen. And there's other directories which you can look in the documentation for. And let's talk about how we find out what these directories are inside of our app. And we're going to do that using something called the file manager. The file manager is an object, a struct, that lets you, as its name implies, manage the files in your file system, including finding out where these special directories are. Now, there's two different methods for doing this. I'm giving you here a little more complicated one. There's a slightly simpler one which is called URLs. This one's called URL. I'll use the simpler one in the demo, so you'll get to see them both. So this file manager, how do we use a file manager? Most of the time, if we're working on the main queue, which we are, most file operations happen quick unless we're writing a gigantic file. So we can do them on the main queue. They're not going to block like a network operation would. We get this usually file manager default, file manager.default, which is the shared one. Now, you probably wouldn't want to use that one off the main queue. There you'd want to create your own instance of file manager. Again, kind of an advanced topic. So we're usually going to use the shared one on the main queue, and the function that we're going to call on this shared file manager.default thing is called URL for directory and domain mask, and it's got these other things appropriate for and create. So what are the four arguments here to this URL thing? The first one is which of the special directories you want. So this is an enum, file manager.searchpath directory. Go look in the documentation, and you will see, I think there's 12 or 15 different special directories inside your sandbox. So this is like the document directory, application support, caches, all the things we talked about. There's an enum value for each of those. The second argument is in domain mask. In iOS, this is always user domain mask because on a Mac, we might have the network domain, a shared library where we're looking for it. On the iOS device, it's a personal device, so it's always user domain mask. Don't worry about it. Appropriate for create. If you're writing to the document directory for the first time, for example, you would want it created, so you probably are going to put create true when you do this. And that's going to return for you the URL to these special directories. So now that you have a URL to the special directory in the sandbox, you can start creating or looking for files in there. So how do we do that? We do that with methods in URL. So we've got this base URL, and we're going to use methods in URL like appending path component and appending path extension to build a path to whatever file we're looking for inside these special directories. Simple as that. You can also ask the URL things like, is this the URL of a file versus a URL of a network thing, a web page? And you can ask the URL, give me values for certain resources in this file, like its creation date, or whether it's a directory or not, or how big this file is. And the API for this, again, pretty swift, not that weird, except for that you give it the keys of what values you want about this URL, like its creation date or file size or whatever, and it gives you back a dictionary where those keys that you gave it are the keys, and the values are in any. And the reason value has to be in any there, because it could be a date, could be a file size, would probably be an int, those kind of things. So that's how you find out about URL. So URL is an important part of interacting with the file system, just like file manager is. Another important struct is data. Data is how we actually put the data out on the file system. And you already know how to read data from the internet using data's contents of URL. And you can do the same thing with a file URL. So that's how you read files off your disk, out of your file system, is with data. And all same thing with writing. There's a write to URL, and you just send it to a data, and it puts the contents of itself into that URL in the file system. Both of these have little reading and writing options. The writing ones are the only ones that are very interesting. For example, there's write atomically. So if you're writing a gigantic file, and let's say the disk fills up halfway through, the file will now not be in a corrupted state halfway written. It'll just revert back to the state it was before you tried to do this write. So that's an atomic transaction. Like essentially it writes it to a temporary file. If that's successful, then it'll move it into the URL you were trying to write to. File Manager can also essentially help you understand what's going on in the file system, similar to what URL was doing. And it also can do things like show me all the files that are in this directory, or move this file from this URL to this one, or copy this file, make a copy of this URL. And I'm going to show, instead of going through slides and showing you all the things that File Manager can do, first of all, you can just look at the documentation, but I'm actually going to show you in a demo in here in a moment. One thing I want to note about File Manager, it has something called a delegate. Delegate is just a var on it, and that var is an object that you set, and that object will be notified when certain things are happening in the File Manager. As the File Manager goes around, moves files, tries to do things, it's going to talk to its delegate and ask it to do things. Now, this delegate stuff, fundamental to UIKit. Everywhere in UIKit, there's delegates, and we'll see that in our next lecture because we're going to start talking about UIKit integration with Swift UI. But if you're looking at File Manager, you're probably like, what is this delegate thing? I've never seen it before. And I don't think you need the File Manager's delegate to do most stuff in File Manager. We're going to do our demo and never even set the delegate. But I just don't want you to be surprised by, oh, what's this delegate thing? It's essentially just an object that gets notified when things are happening during File Manager operations. All right, so a demo is worth 1,000 words, as we always say, or thousands of words. So let's check it out. What we're going to do in our demo today is store our EmojiArt documents into the file system instead of user defaults, which was silly. That was demoware. Storing in the file system makes a lot more sense. Storing them in iCloud would make even more sense than that. But we will store them in there, and this is going to be able to show us all parts of accessing the file system because we're going to have to get a URL to our documents directory. So we're going to be using URL to do that and File Manager to do that. Then we're going to write our data out, of course, using the data object. And then I'm also going to make my document chooser work. So removing documents, adding new documents are going to have to work. And so we'll have to be using the File Manager to do some file system operations to make that stuff work as well. So let's dive into that demo right now. So the goal of this demo is to make EmojiArt document store stop storing itself right here and EmojiArt documents over here in user defaults. Instead, we want them to store in the Unix file system that underlies iOS. So there's really two things we have to fix. We have to get documents to be storing in the file system, and we have to get the document store to be looking in the file system instead of looking in user defaults. Let's start with the document here, and I'm going to add this capability to the store and to the document to work in the file system and leave this user defaults capability in case someone wants that instead. There's no reason to break what we had before. So creating an EmojiArt document here that stores itself in the file system is just going to be, for me, a matter of a different init. So this init takes a UDID, which it uses to store in default. I'm going to have my init, instead of that, take a URL. And this is going to be the URL to use to read the document from the file system initially, and then also to save the document anytime we want to autosave. We're going to use this URL for that. We're still going to need to set our ID to be some UUID because this ID is part of our identifiable, right? So we still need to do that. But here we're going to also grab a hold of this URL and put it in a little var. we're going to use this URL to load this thing up and to autosave. So let's start with the loading of it up. It's pretty straightforward here, actually. We already know how to load up an EmojiArt from a URL because we know how to get a data from a URL, and we know how to load an EmojiArt from data. So let's just do EmojiArt here, and we're going to pass it some JSON, which is trying to get the contents of this URL from the file system. And if we can't do that, by the way, let's just do a blank EmojiArt, because maybe they gave us the URL that they want us to save to, but there's no such file currently in existence, and so we'll create a blank file for them. So it's the same data contents of that we were using when we fetch things over the internet. We're just using it now with a file URL. We still want to fetch the background image data here from whatever that's coming from. And we still want to do autosave cancelable up here. But of course, we're not going to autosave into user defaults. This time we're going to do our autosave cancelable to sync off of our EmojiArt. For this autosave, we want to essentially save our EmojiArt. Have a little function to do that, a little private func save, which takes an EmojiArt to save. And all this is going to do is do the kind of the inverse of what we did right here with this data. We're going to say if our URL is not nil, in other words, we're the kind of EmojiArt document that saves to the file system, then we're going to try to have our EmojiArt's JSON write itself to our URL. One-liner here to write ourselves out. Now, one other thing I'm thinking I might do is here I'm auto-saving every time it changes. What if somebody changes this URL on me? So my document was writing out to some URL and auto-saving, and then they changed this URL. Well, the next time I autosave, that's okay, it'll write to this URL. But I'm going to be a little more immediate than that. I'm going to put a did set in here, which does save of my own EmojiArt, just to immediately save to a new URL if somebody sets it on me. Probably not critical, but I think if someone sets a new URL on my document, they probably want it to pretty quickly write that thing out. They don't want to rely on the user having to add an emoji or something to cause an autosave to happen. And this is it. That's really all that's required to get our EmojiArt to write itself into a URL, quite straightforward. Now, the other piece of this whole puzzle is back in our store right here, because right now our store keeps the names of all the documents in a little dictionary here, which it's reading and writing from user defaults. We want these names to come out of the file system. So we wanted to look into a URL of a directory somewhere and look at all the files that are in there and use those as the names of all the documents that are in there. So this also is something we can do without breaking our existing init named, where it's going and looking in user defaults. For this, we can just do a new init, and this init is going to take a directory, which is just going to be a URL. And we're going to look in this directory and load up our document names with whatever files we find in here. Now, what's going to be our name? You remember our store has a name. Here we're init with name, so we're providing the name. This is the name of the store itself, not the names of any of the documents, just the name of the store itself. We could have that be an argument here as well, another argument named. For fun, I'm going to set our name here to be equal to our directory's last path component. Now, this might not really be good because maybe this is an internal directory that stores our documents. I'm going to make this eventually be our documents directory. So this is going to look pretty good because I think that's called documents. But I mostly wanted to do this to show you what it looks like to grab the last component out and put it in something that we're going to see in the UI. But in reality, probably want another argument there for the name. And so we're going to grab onto this directory. So let's say self.directory equals this directory. Put that into a little private var directory, which is a URL. So this URL, here's directory, points us to where all of our documents are stored. we're obviously going to want to create this document store, likely with our documents directory in our sandbox. But we'll get that a little bit. Right now, we're going to make this document store so it can work with any directory anywhere. Just you pass what directory you want to its init, and it's just going to open it up and look at all the files that are in there. Now, how does it open it up and look at all the files that are in there? How do we find out what files are in a directory? Well, we're going to use that file manager thing. And it's got a really cool little function. I'm going to call this documents. Let documents equal file manager.default. That's the shared one. Give me the contents of directory. You can see there's a couple of them right here. I want this one, directory at path, my directories path. Directory.path, path right here is a URL method, or var actually, and this var returns this URL as a string. And that's a lot of the file manager things take these paths as strings. Some of them take URLs, but some of them take strings. This one happens to be convenient because it just takes this nice one argument right here. Now you can see we have an error, call can throw, but it's not marked with try. So I could say try question mark here, but I'm going to actually do the dual catch here because I want you to get a look at it every once in a while so that you know what's going on. Otherwise, I'll send you out of this class and you'll just always be doing try question mark, and you won't think about the fact that we can do try without a question mark and catch the error. I did this in one other demo, and we'll do it again here. Now I could just, for now, I would just maybe print this error out, EmojiArt document store. Couldn't create store from directory. Let's print out the directory that was attempted here. And we'll even print out the errors localized description. And we might want to, for example, make this be a failable initializer perhaps, and then return nil in here. So it's kind of how you do error handling. You really want to think in general what your strategy is. Are you going to notify the user? Are you going to try and recover? I'm kind of a fan of trying to recover as much as possible, but by the same token, you don't want to mislead your user into thinking that somehow something that they thought was working did not work, or vice versa. All right, so we've got our documents. This is an array of strings. If you look at it here, array of strings, these strings are just the names of all the files in this directory. It can be simpler. So let's go through each of those. And for each one, I'm going to create an EmojiArt document from what I find in that file. EmojiArt document, and it's great, we just added EmojiArt document URL. So how do I create a URL to this document? This document is a string, it's just the name of the file. And I have the directory right here, so I'm going to take the directory and I'm going to append a path component, which is that document name. So I'm just creating another URL here from our directory URL by adding the document name back in. And I'm doing this for every one of the documents that I found in that directory. Super simple. So now I have this document. I'm going to add this to my own document names, this EmojiArt document, and its name is document. Now we've updated our internal data structure to reflect what's in the file system. We've done this at initialize time. Now we still have quite a bit more work to do up here with all these adding and removing and changing names of documents. We're going to have to keep the file system in sync up there, but at least we've kind of got started here on the right foot by having our internal data structure load up from the file system. That's pretty much all that's necessary to do that. So now let's go back to our scene delegate over here where we are creating this document store called EmojiArt that we get out of user defaults. And instead of doing that, let's go and let our store equal an EmojiArt document store whose directory is a URL. And this URL is going to be our documents directory in our sandbox, that special directory. Everybody remember from the slides how we do that. Say let URL equal. Again, we're going to use the file manager, the shared one. in the slides I showed you this one, URL for search path directory inappropriate for create. Remember that? I'm going to use a different one here. It's called URLs, plural. And you still specify the special directory you want. So I want the document directory. Be careful there. You don't do documentation directory. You want document directory with the document directory. And we always, again, in user domain mask, iOS is an operating system for individual devices, so we're always using the user's document directory, not the shared one on the network or something like that. Now, this URLs version returns an array of them, again, because on other platforms you might have multiple masks here, user mask, network mask, so you might be getting multiple responses. Here we're only going to get one, and I'm going to throw an exclamation point on here in the assumption that I always have my document directory here. And, you know, putting an exclamation point here, if that's not true and this crashes, I'm going to at least find that during my development period. But when it comes time to ship, maybe I'll do something where I use this kind of store if for some reason I don't have a document directory. So this is it. Got this store. Let's run. See what's going on here. All right. So this is probably working because there's no documents here. See, we have no documents, and our file system, our document directory in our sandbox is probably empty, so all is well. And maybe we could add some documents here, but this is not actually adding them to the file system. If I stop and rerun, these documents, no change, of course, because plus is not doing, it's just adding it to our little local document name data structure here in our document store. And so this is having no effect on the file system. So we need to update these things up here, add document, remove document, even set name to affect the file system as well. And that's going to be great because we're going to get a chance to see how do we affect the file system. We already learned how to read the contents of a directory. Now let's learn how we, for example, remove files and things like that. So let's do add document first so we can get some documents going in our document directory here. And add document has a little bit of an interesting aspect to it when we start storing in the file system. When we stored in user defaults, we could have 2 or 3 or 4 documents with exactly the same name. It was perfectly fine. But in the file system, that's not allowed. The file system, you only get one document of a certain file name. That's the way it is. That's the way file systems work. We distinguish the things in the file system by the name of the file. So I'm going to have to be careful here if I'm dealing with the file system to not just use the name that's passed to me or even just untitled default. I have to make sure that name doesn't already exist. And what I'm going to do here is if it does, I'm going to create a unique name. So I'm going to say here, let unique name equal this name that you're asking me to do, uniqueified, and I have this nice function that I wrote called with respect to document names.values. So this creates this uniqueifies this string with respect to these other strings. And these other strings are the values of my document names. In other words, the document names I already know about. Let's take a look at this unique with respect to real quick. It's down here in EmojiArt extensions. It's a real simple little function. It just creates a copy of myself. This is in string, right? Copy of myself. And while I am in this other strings, I'm going to increment myself. Now, what is incrementing myself? That's a new thing I added to string where it puts a number at the end of the string and just increments it as necessary to finally find a unique number. So if my name is untitled and there's something else already called untitled, I'm going to eventually become untitled 1. And if my name is untitled 1 and I do incremented, this little code, which you can look at later, it's kind of fun code actually, is going to go untitled 2, untitled 3, untitled 4 until we find a unique name. It's just kind of simple, tricky thing. But I actually am showing you this, and I use this because I want to show you something else. If we go back to our store, this line of code that I wrote that did that didn't actually work. It says cannot convert value of type dictionary EmojiArt, string.values to expected type array of string. Yeah, indeed, my EmojiArt extensions over here takes an array of other strings, which it wants to be unique with respect to. But back here, this is not an array of strings. If you have a dictionary like document names and you ask for its values, you do not get an array of these things. You get a special type that is a collection of these things. So we're using functional programming here to return something that it's not an array, but it is a collection. Now, my Unified really should be just as happy to work with a collection of strings as an array. For example, a set of strings should work here. If I want my name Unified with respect to a set of other strings, that should work. And certainly, I'd like to be able to pass this values of a dictionary, whatever this collection is. So how can I make this over here so this doesn't take an array of string anymore, but it actually takes a collection, and where that collection has strings in it. To do this is not object-oriented programming, so it's not like a set and array inherit from some class collection. This is functional programming. So we're going to do this the way we always do these things, with a don't care and constraining. So this is constraints and gains. So how are we going to do this? I'm going to create a don't care here, which I'm going to call string collection. So I'm going to uniquify with respect to some string collection. Now I'm not totally don't care on this. It has to be a collection because I want to do contains on it, and it also has to have strings in it because I'm trying to uniquify with respect to strings. So how do I do a don't care with just a function like this? This is not don't care on string or something else. It's just this one little function on its own wants to have a don't care. Well, it does that with angle bracket string collection. It's very similar to doing it on a type, a struct, or whatever. Just do it right here. And I can also do the where. So I'm going to do over here where this string collection is a collection, got to be a collection, and also where the string collection's element equals string. So this dot element is a don't care in collection. Remember that a protocol like collection, it can have a don't care, that's associated types. And so it has one, which is the element, and array has this same one, and set has this one because they're getting it from collection because they implement the collection protocol. So I'm just constraining this to make this work. And look, it just all works because contains is in collection. And of course, we can do things to it here that are string oriented because I'm making sure this is a collection of strings. And not only that, but back here, when I recompile, this is going to work. This is no longer complaining because this is a collection of strings because this is a dictionary that has strings as its values. I just wanted to take a little detour from what we were doing to just throw another functional programming thing at you. All right, so we have a unique name here, so we can add our document with this unique name. So let's do that. I'm going to create my document here as a little local var. And then I'm going to say, if I can let the URL, this is going to be the URL for this document that I'm going to add. I'm going to add a new document. So I'm going to create a URL for that document. It's my directory that my store is in, appending path component, which is that unique name. So this is the URL that I would want to create this new EmojiArt document is. Now, I'm doing if let because maybe my directory is nil because someone did init named instead of doing init directory. In this case, my store isn't based in the file system, so my URL is nil, so I can't get a URL for this document. But if I can get a URL for this document, then the document is just going to be an EmojiArt document with that URL. Let's create a new EmojiArt document. If not, if we're just doing the user defaults thing, then the document is just a blank EmojiArt document, a brand new one, because we're in add document, we're adding new documents. Let's pay attention to our error here first though. Oh, yes, indeed, we don't want to be adding blank document here. We want to add this document that we just created. That's why your warnings, got to always pay attention to those warnings. And also, let's make sure that we are using the unique name that we just created as the name of the document there. All right, so we have no documents here. Let's see. plus. Hopefully that created a file in our file system for that. And how about another one? Woo, we got the unique. Another. Woo, it incremented. Okay, so our little increment code worked as well. Now, hopefully when we quit and come back here, those 3 files are going to be in the file system. And they are. Excellent. Okay, next step, deleting. So if we go over here and say, let's get rid of untitled 1. Oh, looked like it worked. Nice. Now let's rerun. Oh, untitled 1 is back. And it makes sense, right? Because we didn't, when we hit in here and said delete, we didn't actually delete it in the file system. We deleted it in our document names. But that's it. All right, so we got to go fix remove document here to delete the thing from the file system. That's probably the easiest of all the things we need to do. We're just going to see if we can get the URL for that thing, which we have to get from its name. That's our document names for that document. And then letting the URL equal our directory and appending the path component of that name. So if this document that we're trying to remove, we've got a name for it, and we can make a URL out of it, meaning that we're a store that's in a directory, and we're just going to remove it. And that's another thing that our file manager can do for us. File manager.default, the shared one, remove item at URL, kaboom. Now, again, like most of these file managers things, this can throw. This one, in this case, I'm just going to do the try question mark because if we're trying to remove this document and I can't remove it, I'm not sure what I'm going to do about it. I suppose I could look at these errors and see if there's one that's recoverable in some way, but probably unlikely. That's it. Remove document, done. Now let's try and remove untitled 1. All right, done. And rerun. Gone. Nice. Add this back, add another one. Let's go here, delete untitled 3. Let's delete untitled. Done. Rerun. Woohoo! Okay. So the last one I think we have here is rename. So if I go edit here and I say, I want to change this back to being untitled, and I hit done, looks like it worked. Let's rerun. Oh no, untitled 1 is back. So again, renaming is having no effect on the file system, so it just comes back and shows you what was in the file system when we rerun. Let's change set name. This one's just a matter of changing the URL for this document right here to be a URL that works for this name. So if I can let the URL equal our directory by appending the path component of this name that you want to set as the new thing, then the document URL equals that URL. I've just changed the place where this is happening. Now, I don't know, one other thing though, what if this is a rename? Okay, someone set the name of a document and it was already around somewhere in our document names with a different name. So we got to be careful of that. How about if we remove the old document? We remove this old document before we change its URL, it'll remove it from its old URL, and now we put it in its new URL. But there's one other thing with naming, a little tricky, similar to add document, which is what if you try to set the name of a document to the same name as some other document already has? Oh, yeah. Well, we could try some unification or something like that. But I actually think the strategy I'm going to use is I'm just going to reject that request. I'm simply just going to ignore it. Again, maybe I want to enhance this func to return a bool, whether I was able to actually do this rename, and then the UI could put up an alert, whatever. We're doing a demo, so I'm not going to do any of that. I'm just not going to allow a rename to happen here if you're trying to do one in the file system and that name exists. So the way I'm going to do that is I'm going to say I'll do this if the document names.values does not contain this name, then I'm happy to rename this for you. Otherwise, I'm not going to do it. And in fact, otherwise, I'm not going to do anything. So let's put this one down here in an else, like that, and then do this up here only if this don't have this name conflict. Well, let's see what happens in the UI if I just take this strategy of just not allowing renames that to another name. So here we go. Let's try. First of all, let's see if rename is working. So here I'm going to do untitled 1. I'm going to rename it to be untitled. That's not the name of something else. That's good. Let's rerun. Ooh, it renamed it in the file system. Okay, now let's try and take this untitled 2 and call it untitled. Done. Ooh, look, it didn't allow me to do that. But when I went back, it was here. That's interesting. So I'll try untitled 1. Oh, that works. Okay, let's add a few more. Let's try and rename untitled 4 to be untitled 2. Done. Wouldn't allow it. Just went back. But when I go back to edit, it's still holding on to that 2 for me. So maybe I really want 21. Or maybe I want 2A or something like that. That it allows. So it's not too bad that we just rejected. I probably would prefer a little alert there, maybe just because the user might be a little confused. They're here and they hit this and they hit done and they think, oh, they did it, but oh, there's that 2A is back. What's going on? I tried to rename that. Yeah, they may or may not notice that there's another one with that name. So maybe an alert that name is already in use would be good here. But we're here to learn about file system, and I think we did that. We showed a lot of different parts of file system here. We started out over in our document just learning how we can use data and URL to change our reading and writing to be going out to the file system instead of user defaults. That was super easy over here. And then when we went to the store, we learned a lot of things about File Manager, this shared file manager, like how to get all the contents of a directory, and then how to do things with the file manager, like remove files. So that is it for this demo, and hopefully you'll have a chance to integrate this into your final project. It's pretty straightforward to do, and usually you do have storage requirements, and I'd rather not see all of your final projects storing everything in user defaults. Definitely would like to see some core data and or file system, and maybe even CloudKit. That would be great.
For more, please visit us at stanford.edu.